Similar to power, when we're working with efficiency, you kind of have to think through the theme of the question, not just look for numbers and plug and chug. Efficiency is a ratio. It describes how much energy was actually converted to what I'm going to call the useful form. To how much energy the device actually used. It's described as a percent, so after our division we multiply by 100. The useful energy depends on what the question's actually dealing with or asking about. And this sort of typical question, since we're talking about a car that's moving, our useful energy is going to be kinetic. If there were another question about an elevator lifting something and asking about the efficiency of that, lifting energy refers back to gravitational energy. But for this one, if we're talking about the efficiency of a car moving around, the numerator gets replaced with kinetic energy. I'm going to short form a little bit down. I'm just going to say efficiency equals 1/2 mv squared over the energy that's used. For this one, if we flip-flop things around, the energy used is going to be our kinetic energy divided by the efficiency. For the numbers made up here, a car with a mass of 1,800 kilograms going 90 kilometers per hour. Oops, almost got caught. 90 kilometers per hour. To use that properly, we have to convert it to meters per second. 90 kilometers per hour is a nice clean one. The conversion ratio is 3.6, or you could do your two conversions, get it into seconds, then get it into meters, but it works out nice and clean to 25 meters per second. The efficiency that I made up, you can Google it, but there's a range for cars. 40% is kind of an acceptable value. When you do the math on that, the energy used by the car is going to be a big number. It's heavy and it's going kind of quick. I get roughly 1.4 million joules of energy.